Hi guys, what's up? I am Sonu and you're watching Mathematics Expert channel. In this video, I'm going to talk about the two different types of numerical problems. This is very important for the JEE exam and any other exam higher for BSc in mathematics. So see carefully, it definitely help you this problem. Now my first problem is show that the angles between the four diagonals of a rectangular parallelepiped are cos inverse related with the cos inverse plus minus a square plus minus b square plus minus c square divided by a square plus b square plus c square, given that ABC being the edges of the parallelepiped. Now the first question is, what is parallelepiped? Parallelepiped means nothing but it is the extension of the parallelogram in three-dimensional space. And what is rectangular parallelepiped? Rectangular parallelepiped means it is the extension of the rectangular surfaces in three-dimensional space. So I think you understand what is the rectangular parallelepiped. Now to solve this problem, first draw the parallelepiped. What is parallelepiped? Let's draw rectangular faces in three-dimensional space. This is one rectangle and this is second one, and now join it. This is joining here and this join this and this. Now take one of the vertices at origin of the parallelepiped. Now take one of the vertices O, name it O, of the parallelepiped as origin and three rectangular faces through it as three rectangular coordinate planes. This is coordinate plane. This is X, named it. This is Y, and this is Z. And other planes are parallel to the coordinate planes. Now named it. This is A. This is A. And this is N. This is B. This is C. This is A. O. This is M. This is L. Given that the length of the edges of the parallelepiped are A, B and C, so this coordinate must be A is A, 0, 0 and B must be 0, B, 0 and C must be 0, 0, C. And what is the coordinate of A? A is A, B, C. And what is the coordinate of L? Because L is in which plane? YZ plane. So X coordinate of this point is 0. So X coordinate is 0 and Y coordinate is simply B and Z coordinate is C. This coordinate is, this point is in XY plane, so Z coordinate is 0. So coordinate of this point is A, B, 0. This point is in the XZ plane, so it has Y coordinate 0. So it has A coordinate is and Y coordinate is 0 and Z coordinate is C. And you know what is, this is origin. Coordinate of origin is 0, 0. And first a simple concept. Note, since first point is let x1, y1, z1 and second point is x2, y2, z2, then the direction cosine along the line joining of this line AB, what is this? You know the direction cosine. Let's remember this formula. Direction cosine is x2 minus x1 divided by length of AB and y2 minus y1 divided by length of AB and z2 minus z1 divided by length of AB. This is the direction cosine of the vectors along AB of this line AB. So you know the coordinates of all points A, B, C, L, M, N and origin. Now the direction cosine along the line OP. Now the direction cosine of the line OP are A divided by summation A square, B divided by square root of summation B square and C divided by square root of summation summation A square and summation A square. This is direction cosine along OP. Now direction cosine of the line which AL, just see the figure, minus A divided by square root of summation A square and B divided by summation A square and C divided by square root of summation A square. And similarly the direction cosine of the line BM is A divided by square root of summation A square and minus B, just see the figure, minus B A square and C divided by summation A square. And similarly, and the direction cosine of line, the line CN. CN, just see the figure, where is CN, where is N? C is here and N is here. So direction cosine of C is here and difference is A and B and minus C. So put it. Direction cosine of CN are A divided by summation A square and minus B divided by A, just see the figure, A and B and minus C, Cn, A summation A square and minus C divided by summation A square. This is direction cosine along line Cn. Now the angle between line OP, the angle between the line OP and Cn is, let the angle is theta, then cos theta, you know what is cos theta? The cos theta is the sum of the product of the direction cosine of this straight lines divided by the magnitude of this, divided by the square of the direction cosines of this straight line. So this is multiply, this is A, B, C and this is A, B minus C. So A square plus B square minus C square divided by A square plus B square plus C square. That is theta is equal to cos inverse A square plus B square minus C square divided by A square plus B square plus C square. This is the angle between them. Similarly, the angle between any one of the angle between any one of the six pairs of diagonal pairs of diagonal can be found. Understood it? This is very simple, not difficult problem. And again, I have a very interesting problem. If L1, M1, N1 and L2, M2, N2 and L3, M3, N3 are the direction cosine of the three mutually perpendicular lines, so that the line whose direction cosines are proportional to L1 plus L2 plus L3 and M1 plus M2 plus M3 and N1 plus N3, N2 plus N3 makes. There is some missing in the problem. Makes equal angle. Equal angles with them. Just prove it. Since given that L1, M1, N1 and L2, M2, N2, L3, M3, N3 are the direction cosine of three mutually perpendicular lines. So, since the given lines are mutually perpendicular, hence what is the condition of perpendicular lines? The sum of the product of the direction cosines is equal to 0. Now do it. L1 L2 plus M1 M2 plus N1 N2 is equal to 0. For this line, this is condition. This is condition for line 1 and 2, which is perpendicular to each other. Now apply the condition for line 2 and 3, which is perpendicular to each other. For line 2 and 3, what will L2 L3 plus M2 M3 plus N2 N3 is equal to 0, and for line 1 and 3, L1 L3 plus M1 M3 plus N1 N3 is equal to 0. We have these three equations. Equation number 1, this is equation number 2, and this is equation number 3. This is the condition for three mutually perpendicular lines. Now the question is saying that the line whose direction cosines are proportional to L1 plus L2 plus L3, comma M1 plus M2 plus M3 and N1 plus N2 plus N3 makes equal angle. Let theta be the angle between the line whose direction cosine are L1, M1, N1 and the line whose direction cosines are proportional to, that is L1 plus L2 plus L3, comma M1 plus M2 plus M3, comma N1 plus N2 plus N3. In question it is given that direction cosines are proportional to this L1 plus L2 plus L3. That is, it is not a direction cosine, it is direction ratio. Because you know what is direction ratio? Direction ratio is nothing but direction cosine which is proportional to some number. Direction ratio is any number multiplied with direction cosine. So apply the condition for angle between two straight lines. That is, cos theta is equal to L1 into L1 plus L2 plus L3 plus M1 into M1 plus M2 plus M3 plus N1 into N1 plus N2 plus M3 divided by this very interesting problem, divided by a square root of L1 plus L2 plus L3 the whole square plus M1 plus M2 plus M3 the whole square plus N1 plus N2 plus N3 the whole square into 1, because L1 square plus M1 square plus N1 square is equal to 1, equal to L1 square plus M1 square plus N1 square plus, let's see here, L1 L2 plus L2 and not L3 L1 plus M1 M2 plus M1 M3, which is plus N1 N2 plus N1 N3. Now see here, L2 L3 M2 M3 and N2 N3 is 0. So the value of this here L1 L2 M1 M2 and N1 N2, this is 0, and L1 L3 M1 M3 and N1 N3 is also 0. So this is complete value is 0. So and divide by root under L1 square plus L1 plus L2 plus L3, that is summation L1 square plus summation L2 square plus summation L3 square, that is L3 square means L3 square plus M3 square plus N3 square plus again 0. So what we conclude from here, cos theta is equal to 1 divided by root under 3. This is a special things, independent of which L1 M1 N1 L2 M2 N2 L3 M3 N3. Hence we can say that the given line makes equal angles with the three lines. Because cos theta is independent of L1 M1 M1 L2 M2 N2 L3 M3 N3. So for any values of L and M and N, cos theta is simply 1 by root 3. So here we are able to prove that line whose direction cosines are proportional to L1 plus L2 plus L3, M1 plus M2 plus M3 and N1 plus N2 plus N3 is proportional, makes equal angle with them. Thanks for watching this. I am going to stop here. If you like this video, if you understand clearly, then like, subscribe and share to your friends. I am just